All right, let's dive in. Today, we're going to pull back the curtain on one of the most famous and maybe infamous tools in all of math, the quadratic formula. But this isn't about just memorizing some random equation. This is about finding a master key, one that unlocks a whole category of problems that you see, well, pretty much everywhere. So let's get started.
You've seen this shape a million times, even if you didn't know what it was called. It's the path of a basketball heading for the hoop, the curve of a satellite dish, the graceful swoop of cables on a bridge. You're looking at a quadratic equation in action. This perfect U-shape is a parabola, and it's the beautiful graph these equations make. And really, our whole mission today is to figure out how to find the exact spots where this curve hits that flat horizontal line, the x-axis.
So, what's the actual problem here? What are we trying to solve? Well, it all boils down to any equation where our mystery variable, our x, is squared. That little x squared is the magic ingredient. It's what creates that distinctive parabola shape and gives these equations all their special properties.
Okay, so take a look at this. Every single quadratic equation out there can be neatened up and organized into this standard form. You've got your a, which is just the number hanging out with x squared, b, the number next to x, and c, the number all by itself. And our goal is always the same. Find the value, or maybe values, of x that make the whole thing equal 0. That's it.
Now, before we bring out the heavy machinery, let's start with a simpler tool, factoring. You can think of factoring like having a very specific key for a very specific lock. It's clever, it's elegant, and it's super satisfying when it works. But here's the catch. It's not a universal key.
Okay, let's actually try one. For a straightforward equation like this, we're basically just solving a little puzzle. We need two numbers that multiply to get our c value, which is 12, and those same two numbers have to add up to our b value, 7. So you think about it for a second, and boom, 3 and 4, right? 3 times 4 is 12, 3 plus 4 is 7. Perfect. So we can rewrite the equation as x plus 3 times x plus 4 equals 0. And for that to be true, one of those pieces has to be 0. So either x is negative 3 or x is negative 4.
That was pretty clean, right? But what happens when that a value, the number in front of the x squared, isn't a nice simple 1? All of a sudden, that neat little puzzle, it turns into a real headache. Guessing and checking just doesn't cut it anymore. And this is where we start to see the limits of this simple method. Now, for those tougher cases, people have come up with clever tools like this, the box method. It's a much more organized way to tackle the problem. You multiply a and c, find the factors, fill out the grid, and pull out common factors. It's a really great visual trick, but you know what? At its core, it's still factoring. It still depends on you being able to find that perfect combination of numbers.
So here's the bottom line. Factoring is great, but it only really works when the numbers are friendly and play nice. But let's be honest, in the real world, numbers are often messy and complicated. What we really need is that master key we talked about, a single tool that can unlock any quadratic equation, no matter how gnarly the numbers get.
And that, my friends, brings us to the hero of our story. A formula so powerful, so reliable, it can solve literally any quadratic equation you can throw at it. I'm talking about the universal solver.
But you gotta understand, this thing didn't just fall out of the sky. It's the end result of a hunt that took almost 4,000 years. We're talking ancient Babylonians trying to solve problems about land area. Fast forward to mathematicians in India like Brahmagupta, who was one of the first to say, hey, maybe there are two answers, all the way up to René Descartes, who finally wrote it down in the modern form we recognize today. This was a team effort that spanned the entire globe and millennia.
And here it is, the quadratic formula. I know, it looks like a monster, but trust me, it's just a recipe. That's all it is. You take your a, your b, and your c from that standard form we talked about, you plug them into their designated spots in this recipe, you do the arithmetic, and it spits out the answer for x. Every single time.
So where did this amazing recipe even come from? It's not magic. Like the quote says, it comes from a process called completing the square. Think of that as a clever way to rearrange any quadratic equation. And what some brilliant mathematicians did was they took the generic form, ax squared plus bx plus c, and applied that process to it. They solved for x in general terms, and what they ended up with was this formula. It's the solution that works for everything.
Okay, but here's where it gets really cool. Hidden inside this powerful formula is this little secret feature, almost like a crystal ball, that can tell you about your answers before you even finish the problem. It's called the discriminant. The discriminant is literally just that chunk of stuff living under the square root sign. b squared minus 4ac. That's it. And by calculating just this one little piece, we can predict exactly what kind of answers we're about to get. It's a pretty powerful shortcut.
So, what does it tell us? Well, it's simple. If the discriminant is a positive number, that means you're going to get two different real solutions. Your parabola crosses the x-axis in two spots. If it comes out to be exactly 0, you get one real solution. That means the tip of your parabola just barely touches the x-axis. And if it's negative, well, you can't take the square root of a negative number, right? Not with real numbers anyway. That tells you you'll have two imaginary solutions, and that your parabola never touches the x-axis at all.
All right, the formula is amazing, for sure. But you have to be careful. It demands that you be precise, and it's so easy to make one tiny slip-up that messes up the whole thing. So let's go over some of the most common traps that people fall into.
And this first one? Oh man, I see this one all the time. Remember that little plus or minus sign in the formula? It's there for a reason. You'll almost always have two solutions. The huge mistake is doing the whole calculation with the plus, getting an answer, and then just stopping. You completely forget to go back and do it all again with the minus. Remember, that parabola usually hits the line twice.
And here's another big one, simplifying the final answer. This gets really tricky when you have square roots or radicals involved. You see it right here. Someone tries to combine a regular number with a number that's attached to a square root. It's like trying to add apples and oranges. You just can't. They're not like terms, so they have to stay separate. Okay, so let's do a quick fire round of the biggest traps to watch out for. First, signs. Be so careful with your negatives, especially that negative b at the very beginning. Second, make sure your equation is in standard form before you start plugging in numbers. Third, just slow down and double-check your basic math. And last, like we just saw, don't combine things that don't belong together. And for goodness sake, don't forget about that second root.
So when you look at that formula, I don't want you to just see a bunch of letters and symbols to memorize for a test. I want you to see what it really is. A testament to human curiosity and persistence. It's the final chapter in a 4,000-year quest by people all across the world who were all searching for one single elegant key to solve a universal problem.
You know, this formula isn't just a history lesson. It helped ancient builders map out their projects, and today it helps us do everything from modeling financial markets to plotting a course for a spacecraft. It's an incredible tool that connects the ancient world to our modern one. So the only question left is, what problem are you going to solve with it?